In this lesson, I'm going to provide a brief introduction to using an area model to multiply polynomials, also called the box method. This note sheet that I'm working through right now is available on Canvas if you don't have it printed out and in your notebook already. Feel free to go ahead and get a copy, or there's not too much writing, you can easily just copy it directly into your notebook as we go along. So the title here is Multiplying Polynomials. And in order to learn how to multiply polynomials, I want to first talk about the distributive property, another property involving multiplication. So the distributive property is easy to use when we have a problem where we need to multiply a monomial, which mono means one, a single term, I have written there, by a polynomial, which is two or more terms. Poly means many. So the distributive property is easy for us to use when we're multiplying a monomial by a polynomial, but more difficult when we're multiplying a binomial, which bi means two, like bicycle has two wheels, by a binomial. Or more difficult when we're multiplying a binomial by a polynomial or polynomial by polynomial. Anyway, needless to say, it's a lot more difficult when one of the pieces that we're working with is not a monomial. So what I want you to do down here is practice using the distributive property to find the following products. And we had an assignment on this where I had you guys work with the distributive property and we even did a quiz on it. So there's our monomial, there's our polynomial. In that case, it's actually more specifically a binomial because there's two terms. Monomial, polynomial. This one's called a trinomial because there's three terms, like a tricycle. And then finally over here again, monomial. And now we've got three terms again. So a polynomial, more specifically known as a trinomial. So in using the distributive property, also called our rainbow rule, I want you to find the product here, right? So I'm going to take my monomial and multiply it by both pieces. And I like to write it all the way out. So I'm going to say 2x times x plus 5, times x, right? Then I'll separate with a plus sign. And then I'm going to go back to the green piece again. I'm going to say 2x times the second term, which is 5. You can see here my 2x ended up getting repeated twice. And then all I did was I took those pieces inside the parentheses and placed them there and there. So now I've got separate multiplication problems I need to do. Oops, erased a little more than I was hoping. So two separate multiplication problems to do. So we need to do 2x times x and 2x times 5. And then add the products, add the results together. So 2x times x, let's take care of that guy first. 2 times 1 is 2. An x times an x gets me an x to the power of 2, right? That's to the power of 1, power of 1. 1 plus 1 is 2. Then I bring down my plus sign. Then I need to do 2x times 5. 2 times 5 is 10. X times just 1 is x. And I can see that this is my final answer that I'm boxing here in purple. 2x squared plus 10x, because I can't combine something with an x squared and something with an x. They're not like terms, right? Can't be combined. So that's it. And we're all done. Likes to erase a little more than I'd hoped. So purple box, final answer. I'm just going to go ahead and skip that middle one actually and just work on this one on the far right really quick here. You should hopefully know how to work with the distributive property, and this should be a review. But it is something that people tend to struggle with. So don't worry if you're still struggling a little bit with the distributive property. So I'm taking what's in green there, that negative 4a, multiplying it by the first term, the middle term, and my final term. So I get 4a times that first term, which is 2a squared. Again, just for standardization, I'm going to separate with a plus sign. Then I have negative 4a again as another piece. And I'm going to multiply that by my middle term. Multiply that by negative 5a, which is my middle piece there. So times negative 5a. And then again, separate with a plus sign. And repeat again, negative 4a. I'm going back to the beginning and I'm multiplying it by my final piece, which is negative 2. So 3 multiplication problems to do here because there were 1, 2, 3 terms inside my parentheses. So that first piece, negative 4a times 2a squared. Well, let's do negative 4 times 2, which is negative 8. And a times a to the power of 2, that's like a to the power of 1. Gets me a to the power of 3, because 2 plus 1 is 3. Bring down my plus sign. Next, negative 4 times a negative 5 is going to be a positive 20. a to the power of 1 times a to the power of 1 gets me a to the power of 1 plus 1, which is a to the power of 2, or a squared. Bring down my plus sign. Finally, negative 4 times a negative 2 is going to get me a positive 8. I had an a, so I better have an a in my final answer. And what I'm boxing in purple right here is the final answer to using the distributive property on that particular problem. So not too bad, right? When we had a monomial or a single term outside of the parentheses and we had multiple terms inside, not too difficult to use the distributive property there. So now what I want you to do is try using the distributive property to find the product of these two guys, or the two binomials multiplied together, which you could try to use the distributive property and take that guy and put him there and there. But it'll actually prove to be a lot more difficult for a number of reasons. So I could say, okay, 4x plus 2 times the quantity 3x, and then add 4x plus 2 again, times the quantity negative 3. And you would actually end up getting the correct answer if you did that. What I see a lot of people try and do is just simply take one of them and multiply it in and then just call it good. But that's not the case, right? If you did that, you'd just end up with a final answer that looked something like this. 12x squared, maybe minus 6. And you can see what we're missing here is a middle term with just an x in it, which we can see is actually in the final answer that I wrote right there in the bottom left-hand corner. And so you'll find out really quickly that you do not get the correct answer. Maybe you did, perhaps, but usually right here in answer to did you get the correct answer, you can write no for why or why not. Usually because I forgot the middle term. And that's what's common is if you're not careful when applying the distributive property, you'll lose out on that middle term that often appears in these problems. Because we needed to multiply this times this, and then this times this and this, which might look a little more familiar, these marks. Using the rainbow rule, it's called FOIL, what I just drew there. But we're going to look at something a little different today. So an easy way to multiply polynomials is by using what I call an area model. And I'll show you guys what that looks like. We'll start off a little more simply with numbers and then start introducing variables. So I note here, I got a little asterisk right there, and I note that there are other methods, okay, including FOIL or that distribution I just showed you, but we're going to focus on the area model for a number of reasons. The primary one being that we'll use the area model to factor in a few weeks here. So the area model using numbers. Now one thing that didn't transfer over super well from the Word document were these boxes. So this actually had a box, like a rectangle. Each of these is a rectangle. That's a rectangle. That's a rectangle divided in half, and a rectangle divided in half. So here's kind of what an area model looks like. And an area model is just a shape like a rectangle of which we know how to find the area. All right, take a look at that first rectangle there. So basically what this is saying is I have a side of length 4 and a side of length 2. And what we need to do is find the area of this particular rectangle. And if you remember back to geometry, in order to do that, we need to multiply the two sides to find the area of that figure. So I do 4 times 2, and I find that the area of the figure is 8. Say 8 square centimeters. Okay, let's look at this next piece. Here, let's multiply the two sides. Negative 8 times 4 gets me negative 32. So let's say negative 32 square feet. Okay, this one on the far right. Now we're kind of doing a little bit of the opposite here. And we're saying, what can I multiply by negative 5 to get 35? And if you know your times tables really well in your head, that's easy. If you don't, you take 35 and you do the opposite, right? You divide by negative 5 and you see what you get. If you type that guy into your calculator, I promise you'll get 7. Oh, sorry, actually negative 7. Negative times negative gets a positive. So you can see we can also work backwards and find out what goes on the outside of the box. Here's kind of an example of using the box with a few more pieces involved. So where the two pieces intersect is where the answer goes. So you can see if I drew that 2 down and I drew that 3 across, you see how these two lines are meeting in this box? So I do the problem of 2 times 3 and the answer goes in that first box there. So 2 times 3, of course, is going to get us 6. And then right here in this box, I do 3 times 3, right? Because those are what meet up in that box. 3 times 3, of course, is going to get us 9. And then for a final answer, I need to add 6 plus 9 together. And 9 plus 6 is going to be 15. So that's the area of that box, is 15. Let's try with this one here. -1 times a -4 meet in this box right here. So -1 times a -4 is going to get us a +4. And -4 times a 4 is going to get us a -16. -16 plus 4 is actually going to get us -12. That's our final answer. Let's take a look at some practical applications for applying these boxes. Right here I say that large, difficult multiplication problems can be broken up in this way and actually solved using the box. Here I'll outline this as actually kind of the box, so ignore the gray lines for a second. That would be the box with the numbers on the outside. So you can see we can split the number 35 up into 30 plus 5, right? That's the same thing as 35, and that's exactly what I've done on the left-hand side there. And we split up 42 into 40 plus 2, right? 40 plus 2 is the same thing as 42. So in your head, it might be really difficult to do this multiplication problem right here in your head. All right, you could maybe do it if you wrote it out and use the standard algorithm to solve, but it could take a while. Instead, let's just break it up and we can actually end up doing this guy in our head. So here in this first box on the top left, I'm going to multiply 40 times 3, right? Because they meet in that first box there. And I find that 40 times 3 equals, or 40 times 30 rather, equals 1200. In this box right here, I see that 2 and 30 are what's meeting up. And 30 times 2, 30 times 2 is actually going to get me 60. 60 goes in that box. Here, 40 times 5, 5 times 4 is 20, this is 200. And in this final box, 5 times 2 is 10. Now that I've got all these pieces inside the box, I got to combine like terms, right? And since all these guys are numbers, I know that I can add them together, no problem, right? If I had some variables, I'd need to be a little more careful. But since they're all numbers, we can add them all together. 1200 plus 600 is going to get us 1800. Okay, plus 200 plus 10. 1800 plus 200 is 2000 plus 10. And finally, 2000 plus 10 is 2010. And that's our final answer to 35 times 42 equals 2010. And we just did that by using an area model, right? A lot easier than perhaps multiplying all of that out the standard way. So here I want you to try to multiply 67 times 84. And I want you to figure out really quick, how can you break up 67 into two numbers added together, and how can you break up 84 into two numbers added together? So go ahead and pause for just a second, see if you can come up with that. What's easiest to do is break it up by tens and ones. So how many tens in 60? Well, there's 6 of them. So 60. And then how many tens in, or how many ones in 7? Well, 60 plus 7, of course, gets us 67. So I'll say 60 plus 7. And I'll do the same thing with 80 plus 4 gets us 84. So that's what I'm going to write across the top of the box there. I'm going to say 60 and 7, and then 80 and 4. Pretty easy, right? Now let's go and do the multiplying. And this is where you really got to practice. Where the two terms line up is where they go in the box. So 8 times 6, or 80 times 60 rather, is 4,800. Really big number, wow. 80 times 7 is 560. Make sure you use a calculator to check your work. 60 times 4 is 240. And 7 times 4 is 28. And then once again, since these are all numbers, they're like terms, right? They can all be combined together. We're combining apples with apples, not apples with oranges. So I can add all of these pieces together individually and come up with a final answer. And so this is definitely one that I'd suggest using your calculator for to check both your multiplication and your addition. But if you do all of this correctly and you add them all together, you should end up with, and assuming I did, you should end up with 5,628 as a final answer. So the answer to the question, what's 67 times 84? It's 5,628. And we found that in a lot cleaner way than actually trying to use the standard algorithm. So those are just examples, kind of run through quick refresher on the distributive property, gave you a little exposure to the area model and how to use it using numbers. And in another lesson video, I'll actually show you how to start using the area model with variables.